Welcome to The Explainer. Today, we're diving into something truly incredible, the quest to teach computers how to understand language. You know, our language. So, let's start with a really simple question. How do you teach a machine to read? I mean, it sounds easy enough, right? But believe it or not, that one question has kicked off decades of innovation. And that's because, as we're going to see, human language is just, well, it's messy, it's subtle, and it's way more complicated than you might think. Just take a look at this sentence. We saw her duck. Now, for you and me, our brains instantly process the two possible meanings, right? Did we see someone literally duck down, or did we spot her pet bird? That, right there, is ambiguity. And for a computer, it's problem number one. And hey, it's not just ambiguity. Think about it. We've got slang, we've got typos, all kinds of jargon. Then there's context. You need real-world knowledge to get what's being said. Plus, all the hidden meanings, the tone, even just figuring out where one word ends and the next one starts. For a computer, our everyday language is basically a minefield. So, okay, faced with this massive, massive puzzle, where did the early AI pioneers even start? Well, the approach has changed a lot. At first, it was all rule-based. People literally sat down and hand-coded every single rule of grammar. Can you imagine? Then we moved on to statistical models, which were smart enough to learn patterns from huge piles of text. And that brings us to today, with neural networks that, kind of magically, learn all the rules and the context all by themselves. All right, so the very first step in this whole thing is called lexical analysis. Basically, before a machine can understand a sentence, it first has to be able to see the words. See the individual words, the punctuation. This is the part that breaks a stream of text down into these meaningful little chunks we call tokens. So you've got this raw text that gets fed into the lexical analyzer, and what comes out is this nice, clean, organized stream of tokens. It's like the machine is just identifying the absolute basic building blocks of the language before it can even think about doing anything more complicated. Okay, so once the machine can see the words, the next job is to figure out the grammar, and that's where syntactic analysis, you might also hear it called parsing, comes in. This is all about the model figuring out how all those words fit together to make a sentence that actually makes sense, grammatically speaking. What the machine does is build a kind of sentence tree, just like this. It breaks everything down into its parts, the subject, the verb, the object. You can see exactly how the wise dragon connects to the action, imitates a duck. This grammatical blueprint is absolutely crucial for understanding what the sentence actually means. But, even with all this clever grammar stuff, the early models had a huge, huge weakness. They were really bad at understanding context over long distances. So in a long sentence or a big paragraph, they'd get lost. See, these early models read a sentence just like you'd think, in order, from left to right, one word after another. But the problem was they had a terrible memory. Seriously, by the time they got to the end of a long paragraph, they'd pretty much forgotten the important stuff from the beginning. And then came the massive breakthrough that solved this problem. It was called the attention mechanism, and it's actually a pretty intuitive idea. Think about how you read. You don't treat every single word with the same importance, do you? Nope. You naturally pay more attention to the key words. Well, this mechanism gave models that exact same superpower, letting them connect related words even if they were super far apart in the text. And this brilliant, almost simple idea became the engine, the absolute core of a brand new type of model architecture that was about to change everything. And that architecture was called the transformer. So, what happens when you take this incredibly powerful transformer idea and you just scale it up? I mean, massively. You give it an unimaginable amount of data and a wild amount of computing power. Well, what you get is a large language model, an LLM. These are those giant pre-trained transformer models that are behind the tools you hear about constantly, like ChatGPT. They're really the peak of this whole journey we've been following. And the way these things are made is just fascinating. It's basically a three-step process. First is pre-training, where the model pretty much just swallows a giant portion of the internet. It's learning grammar, facts, reasoning skills, all of it. Then it gets fine-tuned. That's where it's trained on high-quality examples to learn how to be helpful and actually follow instructions. And finally, it's ready for what we call inference, which is just a fancy way of saying it's ready to answer our prompts. And the results of all that training? They're literally everywhere now. This tech is being used to tackle some seriously tough problems. We're talking instant language translation, summarizing super dense documents, powering the dialogue systems we talk to, and even helping us create brand new content. But of course, with all this incredible new power, it comes with a whole new set of challenges and some really profound responsibilities. For one thing, there's just the sheer scale of it all. I mean, building and operating these models takes a truly staggering amount of data and computer power, and that has some very real environmental and economic costs we have to think about. And there's this other really weird and critical flaw: they can hallucinate. This is when the model just makes stuff up. It'll generate an answer that sounds totally confident, totally plausible, but is just factually wrong. Or sometimes it's just complete nonsense. And this all leads to some of the biggest, most important questions we're facing today, right? Like, how do we make sure these things are fair and don't just amplify our own worst biases? How can we possibly understand how they make their decisions? Who's responsible when the AI messes up? And what about our privacy? These aren't just thought experiments anymore. We're dealing with this stuff right now. You know, when you look back, the journey from writing simple grammar rules by hand to building models that can actually talk with us, it's just been remarkable. But it leaves us with one last big question to think about. We taught machines our language, so what are they going to say next?